This is a brief overview of the pathMu equipment. What you see here is our tool for sidewalk data collection. On the inside of the box here is a high capacity battery to last all day for data collection. We have our computer board here to operate and collect all of the data. We have a few sensors that I'd like to cover. On the board is a high accuracy inertial measurement unit that captures slope data. On the front that you can't see inside the box, there's a laser sensor that captures the profile of the surface and identifies things like roughness and level changes. On the wheel, we have a accurate wheel encoder to capture distance traveled to match the profile and get high accuracy location. We have a touchscreen interface that I will show you here shortly of how the equipment and how it works and operates. And then lastly, on top of the camera mast, we would mount a geocam camera to capture 360 imagery. This is a demo of the pathMu interface. When you log into the app, this is what you see when you log in. This is a map that has been downloaded for a particular project. We do everything offline so that we do not rely on Wi-Fi. You can move around and zoom in and out and see the areas that are needed to be collected as red reference lines. In this case, they were street center lines, but for the project with City of Los Angeles, we will have sidewalk center lines. The green lines identify where has been collected to ensure a complete data set. The device is not connected right now, but these items are checked off whenever the sensors are connected to the tablet interface. We also have various items on the right here. The top, we have configurable flags, we call them. These are hotkey presses to accurately locate various objects down the path by a simple touch of the interface by the technician. We have various drop-down items for things like width, material, path type, or areas where we cannot collect data that we call obstruction types. These are things like construction or sidewalks that don't exist or vehicles parked on the sidewalk. The way it works is you select your starting location, you press the start button, it lights up, you start walking with the equipment, and you can either stop the run, the stop length of data collection, or you can pause the data collection, take a note, press a flag, change the material or other items, and then you can unpause it, continue your data collection until the end of the block. Then once your run is done, a line feature here is created based off of the data that has been collected. We collect images every 10 feet as well as 360 imagery from geocam sensors, as well as the GNSS accurate location data, so that we can make sure that data and these polylines are accurately placed over on the map, as well as using having the capabilities of integrating a high definition aerial imagery into the map to ensure GIS accuracy. At the end of the day, the technician syncs the data, and the map is synced with the live map. Data is automatically uploaded every night at midnight so that all the information is on our servers and can automatically start to go through a post-processing system. And so that is our short demo. All of these items on the right here are configurable based off of the particular project needs. Thank you. This is a brief demo of the CurbMet interface. So what you see here is the initial map that appears for the technician in the field. The map is downloaded. CurbMet operates off of downloaded maps. We do not rely on Wi-Fi, so the person can operate in this downloaded area. Then you see a number of reference points where they're intended to go and collect data. So the first thing the technician does is select the location of where it is that they're placing their point, or they can place a new point at the opposite corner right there. They go to the type of curb ramp, and these are all configurable based off of the project. For this one, we used the Caltrans design style and built that into the interface here. And plus, we can add other asset types such as pedestrian signals, bus stops, shelters, crosswalks, other similar data. So the technician selects the type of curb ramp that they're measuring. They have a list of qualitative attributes. They go from tab to tab here. They have a list of qualitative attributes, and they can select the type of from the drop down here. And based off of the criteria that they select, if they select, for example, a detectable warning does not exist, then those items go away, or they have to complete the necessary items to have a complete data set. They move on to take a photo, and I have my finger over the lens, so you cannot see me at the moment, but the technician just selects the image and it takes a picture. They can also delete the photos, and these are the ones that will be submitted, any number of photos as necessary. This photo tab can be ignored for now. They move on then to the measurements, and it shows an image of everything that it's necessary to be collected. They simply place the device along the running slope of the ramp in a position, press the running slope button, and then it will take that measurement within 2 seconds and populate the number here. I do not have it connected to my computer right now, so the numbers will not appear. Similarly, for width and length measurements, they would press the button, push the device to measure the width, and then once they wait for a half a second, it automatically populates the measurement into the this item here. We have built-in air handling to make sure data seems accurate and complete. The technician can add various notes that they feel necessary, and then they go ahead and submit. It will tell you a list of items that are missing, so you can go back and either complete that data, or you can actually choose to ignore that and submit it anyway. And once you submit it, it will take you back to your location. After submitting, you can see the blue icon of where the curb ramp was submitted. We have built-in calibration to ensure accuracy, and as well, the technician can download a new map for This is a brief demo of the pathVu dashboard and data capabilities. This is an example of a project that we completed in Chino, nearby to LA. As you see here, you can see the sidewalk centerline segments as connected 10-foot segments. All of the data is contained within each segment with unique IDs, unique score, data calculations and measurements about all the attributes that we're talking about, as well as an image of what was collected. We can do some filtering to show surfaces that have a score between 80 and 100, which would be the good ones, or you can do things between 0 and 50, which would be the the poor conditions. Similarly, you can filter by level changes, say above a ½ inch, and it will identify all of the level changes above a ½ inch. You can then view the table by the map extent or by the data, and you can export these locations. All of this type of data will be integrated into OpenGov. You can export this as a separate layer. You can filter from the layer itself. You can also search by particular flags, such as low clearances or overgrowth or similar attributes, to identify those locations as well. Then other things that might be of interest is looking at all of the segments that are within a particular radius, such as those within the 1 mile radius of the venues, or other particular points of interest, using attributes such as this, polygons, to search within a particular area of those. Then we can look at curb ramp data, and similarly, everything is color coded. You can see the condition. All of the data is associated with that particular ramp. We have related images as well, and then I can do some filtering based on the score, say looking at those that are less than a 5, and viewing those and prioritizing those. I can also then filter by just the detectable warnings that need to be installed, which might be a lower cost project compared to installing or ripping out new surfaces. And you can see that here where I can select those, and there are all of those that are missing an appropriate detectable warning surface. We also have capabilities of filtering by ADA compliance or individual compliance based off of those individual measurements, as well as being able to show the sidewalks as block faces rather than individual 10-foot segments. Those are not shown here, but it would average and aggregate the data across an entire block, so you can view from a 30,000-foot view the condition of these sidewalk segments. And that is our short demo.